All right. Well, since Synapse came out about 6 months ago, we've had the opportunity to do a couple little projects. One we've completed, one is currently in development, and I thought it would be interesting to walk through and show people Synapse and some of the options that you have and what we chose to do for a client of ours. I know there is some discussion out in the world about what a data lakehouse is, and what we did was basically a data lakehouse in the narrow sense. And I can talk about that a little later, but some definitions of data lakehouse is one platform that does it all, and it can be very big. And I forgot to introduce myself. Uh, I'm Steve Richardson. I work for Iteration Insights. I'm an analytics architect. Uh, I've been doing business intelligence for about 20 years, and before that, another 10 years of custom development. So let me continue. Our client is Colleges and Institutes Canada, which is basically an organization of non-university colleges. So colleges, institutes, CEGEPs, my French is probably bad, and polytechnics. It operates in Canada and internationally, representing the interests of colleges across Canada, sharing Canadian educational approaches internationally through various international projects. And that's sort of where this project comes in. They have these international partnerships. And what they do is they set up programs and projects to help lesser developed countries educational systems to have, more sort of advanced country experience. So, it would be things like, they would take computer science courses or medical courses, things like that, down to Guatemala or other Central American and African and Asian educational systems. And then they help them do this training. And a lot of what they want to do is they do a lot of training of women to reduce inequality in that sense, to reduce poverty by providing this training to people and getting these programs going in the lesser developed countries. But what they had with this was they do have problems reporting on these things. Each and every program basically is set up by a different group within colleges of CICAN, Colleges and Institutes Canada. And how they get the results is they go through a third-party survey tool, which has international reach. It's in the cloud. But so these things can all be different. Questionnaires are all different. The surveys are all different. The languages the survey is in is all different. And then when people have responded to these tools and a suitable amount of time has passed because they don't want to do it multiple times, they would manually extract the data from the website, and then they would manually copy that into a final report. Very time consuming. They had no sort of ongoing situation where they could, publish the survey and watch the survey results come in. They had to wait until, someone could manually extract all those results and build a final report. So they had questions about how could we make that easier for them? How could we make it faster? Are there tools out there that they could use to make their life easier to do all this reporting? So in addition to that, they had some other asks for us that, like many other companies and organizations in the world, they see all that's going on in the data world, and they're very interested in making better use of their data. They would like to do some sort of analytics on this survey information beyond just reporting. They have a whole bunch of a bunch of the survey fields are text-based. You know, they would be interested in seeing what sort of sentiment some of these text fields had, and some of the responses are. Any way they can improve these programs that they're offering internationally. But what was very sort of important too is we're not talking huge scales. There's only a certain number of programs a year. There's only a certain number of people, and that's usually a couple hundred to several hundred people who would be enrolled in one program. The program would run across multiple institutions, but we're not talking hundreds of programs. We're talking 10, 20, 30 programs a year tops. And because they were just sort of dipping their toe in the water, they really wanted to minimize the total operational costs of this going forward. Because they're not sure, or they were not sure that this would really help them. And it was the first step into analytics at all and any sort of automated reporting. The previous reporting system was Microsoft Word. Now they're using Power BI, that sort of thing. So they really wanted to minimize the operating costs. And then this survey system is called ONA Surveys. Quite an interesting service. It allows you to create all these surveys. You can create the survey in any language. The languages we primarily used for this project were English and Spanish. They do have other ones out there in French, and I forget the name of the language, but it's one of the main African languages. Then when they do these queries, there's multiple different questions types they can use. Each question type can have a different structure. And like I said, it could be in a different language. It could be fixed format. It could be select one of, a drop down, select multiple or other, add text, all kinds of choices. All of these things lead to the files we can pull. And the API provided JSON files. The survey representation is the actual survey that was asked of students, educators, employers, these things. And that's where this very complex question structure comes in. And the JSON file it'll give you is complex JSON, which means it has nested objects, nested arrays, could be multi-level deep, has lists of lists of lists, or arrays of arrays of arrays. So it can get very complex. Whereas the survey submissions of the students answering the questionnaire, the employers answering the questionnaire, the survey, the schools answering the survey, is really a simple JSON file. So for all those reasons, we basically suggested that we use Synapse. And the big definition of Data Lake is, yes, Synapse is a platform. It has massive analytic capacity, massive data capacity. You have many, many choices to compute, store, ingest, output data, and do some advanced analytics, everything like that. What the buzz phrase on the left over there doesn't necessarily say is you can actually go really small too with Synapse. And in our case, that's what we did. The old SQL data warehouse is the SQL provision pool. SQL on demand is serverless. Apache Spark pools is what we used, and then we used the data lake. We didn't use any data warehouses. We didn't use any Spark tables, but we did use data factory pipelines, and the data was consumed by Power BI. But there are massive choices in Synapse that you can go multiple different ways of doing different things. It can be very complex. You can process petabytes. In our case, we're the total other end of the scale. We're, doing kilobytes and megabytes at best. So here's sort of what I meant from, this is the top of the file of one of the survey representations of being complex JSON. Everything that you see there where it says children, you're into another object and another array. So even on this screen, we're down 3 levels already. I think the total was it goes down 5 different levels, but not consistently. It is a ragged hierarchy, so some questions would only go down 4 levels, other questions would go down 5. How we process it would have to depend on the type field. So there were arrays, or child arrays that it did provide that we didn't actually want to go into, because other things that the JSON would give you is basically definition of how the survey is supposed to be represented on the output page when they look at it on the web. We didn't want that information. We just want the section, the question, and the answer. So as opposed to something like simple JSON, where you could load this up into your data lake, use the serverless SQL to parse through it, and easily sort of get a view of the data. And that's what this example is. Here, the .data is what the other file called child or children. You just parse through it, you can select it up. The view creates a very simple view of the underlying data in the data lake. It costs dollars per terabyte to run this stuff of data. So it's a very simple and good way to use on simple JSON files. It also works for CSV files. I just put this in as an example that you can, when you output the data into the data lake, if you set it up like a file structure that has year, month, day, you can actually use that file path as part of your query criteria. And that's one way of, not looking at the whole set all the time, that sort of idea. So those are options that were there, but because of the complexity of the processing of that JSON file, we couldn't use these simple JSON, simple CSV approaches. We had to actually figure out and use Spark notebooks to process the files. So we simplified down the Azure workspace to something that would work for CI/CAN. We have our cloud source over there on the left, which is the ONA API. We have another source of SharePoint in the cloud that we used for which specific surveys they wanted to pull down. They had lots of different surveys like a COVID survey, various other surveys that did not relate directly to the results of a specific program. They wanted to filter all those out, so we gave them the ability to say, okay, I want these surveys to be brought in for processing. Another thing I'll talk about shortly is part of the issue of that JSON file was that because it was being set up by different groups and different people in different languages, there was very little structure that you could automate the development of dimensions. Take one of the very important ones they had was the gender, going to the inequality aspect that they want to promote. It would be a different question. It could be in a different language. It would have a different question code. It would be in a different section of the survey based on who wrote the survey. So there was no consistent way for us to coming into a survey to say, this is going to be a dimensional field. That was set up in the SharePoint. So they would say, okay, for this survey, question X is the gender dimension. Question Y is another dimension they want created for them for this reporting. And like I said, then we had the simplified Synapse environment. We ingested the data with Data Factory. So it would copy the fields, the surveys, the representations in from ONA, would write it out to the raw folder. Then it would call the Synapse compute processes, in our case, which the Apache notebooks. Apache Mayor would have an intermediate staged table. It would save some pre-processed stuff in the staged folder, and then it would finalize our fact and dimensions in the curated folder, which is the only public folder that Power BI would read. The only compute engine, as you can see, was the Apache Spark notebooks. So it simplified the process down a whole bunch.
Steve, if I could interrupt you, it looks like we have a question from Omkar.
Okay.
Hey, hi. So I have one quick question here. So as you mentioned that Synapse is a limitless analytics service to bring the enterprise data together and for big data analytics, right? So and then you can use the ADLS Gen 2 where you can have all the JSON files or maybe the flat files to get into the Synapse. So my query is, because you showed that in Synapse you can write the SQLs and then you can do all the processings done, right? So for example, if you have the data available in the ADLS in the form of JSON, and you want to get that data into the platform to do maybe historical preservation operations. For example, I have a flat file of 10 columns and I need to build a model out of it, which is as conventional as any type 2 table. So in that case, what do you think? What is the better way to do it? Is it Synapse or going for the Azure Databricks? Because in Databricks as well, you can do the merging of those and then create the model with the script. So what difference exactly is between Synapse and Databricks in that way, if I consider?
Hopefully there's no one from Microsoft on the call, but yes, it's strange that a lot of those services that are built into Azure Databricks are services that are also built into Synapse. You have choices. There are differences in how the pool runs, the Spark pools, but you don't have to use Spark. It's just you can also use the dedicated SQL data warehouse. It is really going to be on your use case. Our issue was Databricks can be a lot more expensive than this solution for this client, right? The pool is more expensive, the processing, things like that. It really depends on your use case. If you just need a simple view, there is no notebook running here, right? Well, if you use that serverless SQL view, you can just use the serverless SQL views. If it's purely, I need these columns in this view and these columns in that view, you're done. You don't have to start up a notebook. You don't have to do any compute processing because that serverless SQL can do some of that processing for you through those views or through those tables that you can create in there. And you could go that way.
Okay, so just a follow-up question on that. I mean, is the Synapse as well as powerful as what we do in T-SQL? I mean, using merge statements or in that sort?
Basically, anything you can do in T-SQL, you can do in serverless SQL. It's
Okay.
just reading it from the data lake, or you can set up other external services. It could be reading it from another database too, if you wanted.
Okay. Yeah. Thank you. Got it.
So our final curated view of what we could do in our thing is the DIM survey, DIM project, DIM question are the only three dimensions we can really process from the submission that comes back. The DIM disaggregation, that is some pre-processing that we've done that indicates that this field is what you want Power BI to create a dimension in that semantic model in Power BI. We can get to the point to say, here it is, you want this to be the field, but we couldn't really do it because it would be in a different structure, in a different place. It would be in this ragged hierarchy. So it could be 3 levels down, 4 levels down, or 5 levels down within this JSON structure. But we can say to Power BI, hey, this is the field that is actually you want to wrap a dimension around. And then we used a template in Power BI to build that dimension within Power BI. And I think the Power user group is going to go through that solution at some point upcoming. Another thing to remember about a data lakehouse is that these are files. There is no referential integrity here. So when you're doing the processing, you do have to pay attention to that for yourself. You have to make sure that you have unique keys in your dimensions. You have to make sure that it is the same as the key you're creating in the fact file. That sort of deal comes into play. Because other than logic, you don't really have anything that will do that for you other than the code you build. And that is that. So let's go to the environment. You've probably all seen the Azure portal. This is our resource group for our solution. Here is our Synapse environment. These are just our connectors. When you create a Synapse instance, it will automatically create a data lake, Gen 2 for you. It won't automatically create the Spark pool. That comes when you go into the Synapse workspace and you create a Spark pool. Then it will display the Spark pool within your resource group like this. To talk to the SharePoint, we basically, the SharePoint lists, we have a couple logic apps that read that list in, parse it, and create it for us. So the data lake, it's pretty much a standard data lake too. I should mention that all of, when you also create the Synapse workspace, it basically creates a managed service identity for it. Then it connects through to all these other services through that service identity. And that's what it's doing to the data lake. In the data lake, the Synapse folder down here is auto-created by the Synapse environment. I just leave it for Synapse to play with. Sometimes if you come in, it's not displaying right now, there could be a temp folder here. That is also Synapse creating a temp folder in your data lake because it uses the data lake for part of this. The control ones are just where we're downloading some of these values, like the list of surveys they want to pull in or the list of questions that they want to make into dimensions. But we land the raw JSON into the raw folder. So here's the structure, here's a survey, a couple surveys. So in the employer survey, there's our submission JSON file. This is the representation JSON file. You see none of them are huge, but pretty standard structure. Then we have various process steps. These are process files we have internally that we have to use to process this out. What is a little different is, we do have these sort of working file versions, and as you see, they're a little different. And what the difference here is this is the Spark notebook processing the file. When it processes this information, Spark is a partition server. These are the partitions that it used. It used 8 partitions when it was processing the fact file. It only used 1 partition when it was doing the project, because the project is like 3 files or 4 files or 4 records. So you have to be aware that that's how it's outputting the data, because it is just using generic Spark, or, it's not fancied up with like Databricks. This is the raw open source Spark processing engine. And then we basically merge those puppies together and put them into the output file, which is the only folder that Power BI or any of our users actually has access to. Again, you can see some of these are pretty small. So we have kilobytes, we have megabytes, and we have bytes, because this is 3 lines long. There's not very much in it, 4 lines long. Then Synapse workspace itself, very familiar to the usual Azure portal look. You have the overview, your access control, which is exactly the same, uses the same access control as a database or the data lake or Azure Data Factory. It has, I don't think we have it. Oh, we do have an image. It will show you the SQL pool. We only have the built-in serverless pool. We're not actually using this. But if you were creating a dedicated or provisioned SQL, this is where it would show up here. And then you press the new button here. Again, your Spark pools will show up here. You can create them here. We didn't. We created them in the Synapse Studio, which is a web front end that basically has everything you want. So you can go in here and say, okay, my processing pipeline is there. Here are, again, the SQL pools that were there. We just have it's not turned on. That's why it's unreachable. It's not being used. Here's the Apache Spark pool. Wow, that page isn't expanded like the rest of them was. Again, let's see, where will I say? So looking at Spark pool, what I mean, it's a little different. No, this doesn't show very much. Where Shamir was talking about, you can turn the pool on, saves you some money, you can't do that here. When you're in a notebook, you can run the pool, but if you don't run a query for 10 or 15 minutes, I think the default is 10 minutes, the pool will shut itself off. So it's auto start when you start running a notebook, and it turns itself off after 10, 15 minutes, whatever you configure. Our configuration, again, we have very few records, so we're using small instances, 3 to 10 nodes. When we run a notebook, it runs 3. 1 is going to be that the manager, 2 are going to be the executors. That's why we ended up with 8 files for the ones that needed it. It's because 2 are processing, and you've got 4 cores, so you got one file, subfile, for those ones that have been partitioned out when it processed. We only need 9 nodes because we only have 3 notebooks. Each one would start when it runs. In our pipeline, whoa. We'll scroll. Oh. Here is the 2 calls to SharePoint, or these webhooks. This is the first call to ONA to say, give me all our current surveys. Then it would compare the current surveys available in ONA to what has been selected by the organization that they want to see these surveys. Then it would basically get those surveys and look them up and say, okay, this is the code. These are the ones I want to pass in to say, I want this survey, this survey, this survey, this survey. Passes those codes to these for each loops, which are basically going out using pure copy form. So we have the source, we have the sink, it's passing it in, putting it out in the output in the file folder. Wow. It's just start jumping around and scale on me. So we get the survey representation and we get the survey submissions, and then we start processing them. First, we have to go through some steps to process that representation file, to take it out of that 5-level deep, possibly, ragged hierarchy of what all those questions are. And we process that out so we can say, okay, here's the questions, here's the answers, here's the answer codes. And we create this representation file, which this one here, which is basically taking that complex JSON, flattened it into a CSV file with only the parts we care about: the question code, the question section, the answer, and the answer code. This isn't the answer that someone put in, it's the answers that were available to the people to select when they did the survey. Then we take that and we create those 3 dimensions that we can, or 4, because one of them is going to be that disaggregation list. But the project, the question, and the answer dimension. And then we build the fact in the process submission notebook, which takes the answers, joins that to the dimensional keys, basically the question, the answer key, things like that in the survey. And that these last three steps are basically, since we're running Azure Data Factory, we just use Data Factory to take those 8 rows of fact, merge them all into one fact file, just to make it easier for Power BI to consume it. You could also use, where I showed you that view on the serverless, you could also create a view in the serverless that would join all those files up into one file and expose that view to the data warehouse. We used Azure Data Factory at that point because we wanted to put, we wanted to use the flat file data lake as the source. And then where are we for time?
There is a question in the chat for you, Steve, from Shamir. Are there options in Synapse to use user identity to access the data, or is it always a service managed identity?
You can use AAD to make people users, contributors, owners, all the standard Azure AD stuff you can do. Let's see, go back here. Right, you can grant people that access. You can grant them same data lake access that any old data lake would have. You can set up those levels of access there. But yes, you can make them just contributors, or you can make them just readers, so they could only go in and look at the environment, or they could go in and create, there's like 100 roles you can select for people. So here is our survey representation Python notebook. We used PySpark. You have a choice of Scala, C#, Spark SQL. We used Python. This pool, this is that Spark pool that was created. This is not running. So when you say run, it's going to have to create that pool. And yes, it takes a few minutes to run. As far as I know, in this case, Microsoft does not charge you for that time of when it's spooling up. They only charge you for the time that that Spark pool in Synapse is running. But anyways, we don't have to do, as Shamir talked about, you had to install pandas and things like that. That's all pre-installed here, so Microsoft made it a little easier. So all you have to do, as like a Python program, you just have to import it. So we're using pandas, we're using JSON, so it can understand the JSON file. And the read and write within these notebooks, you have to use PySpark. It's just the way it works. So that's what that's sort of there for. Then to save that startup, instead of running this thing 4, 5, 6, 10, 20 times for each survey that it has to do, we create the processing as a function. So then it just goes through that list of 3, 10, 20 surveys and just calls this function for each one. So it only starts the notebook up once and then uses that notebook instance all the way through. Don't want to, I'm probably running along, but I think I have 2 minutes left. So this is what you'd read it in, use a Spark to read it. We then it's basic Python that we're using, basically lists and dictionaries and pandas, and then we just start parsing out the children, and then we parse the children of the children, and we parse the children of the children of the children, and depending if we wanted it or not, we parse the children of the children of the children, and same sort of deal, depending on what type it is, we parse it different ways. Then we take that whole mess we created in a nice little list, we throw it into pandas, into a data frame, so we can use some things are easier to process in data frames, some things are easier to do in lists. So you switch back and forth sort of things to get different things done. We flattened out that list, we get rid of unused columns, and then we say, okay, here are the specific surveys, here are the questions, here are the answers, and clean this mess of JSON up. And again, we have no idea, other than we know there's 5 levels in the JSON, possibly, sometimes 4, sometimes 3, what we're doing. So we just make it as generic as possible, and it will run through all those things. Before we go, I'd just like to say part of the processing was because different question types have different structures, and some of them have multiple answers. So when JSON comes back to you for this question, instead of giving you one answer, it would give you, 5 or 6. Say there was 6 options. It would say, okay, option 1 was nothing, option 2 was nothing, option 3 was nothing, option 4 was answered, option 5 was answered, option 6 was nothing. So we had all these different structures. We don't know which one was answered. We don't want to create a row for everything with no, a row in the submission for no value responded. So this is just cleaning all this mess up to simplify it down so we can just have a pretty standard fact to say, here's the question, here's the answer. Same thing, again, it's doing the same thing on the survey and the cleanup, question IDs, answer IDs, maps that all together. Then we go through much simpler file to go through that, but then we have to map these answers to that representation of the question. So we knew what question it was, and we can say it's answer code X, and for question Y. Process that all out. This is cleaning those things up again, and then we write that file out, and that's basically our fact. That is in that 8 rows. Then the dimensions are just a bit simpler. This is building the questions from that same representation file that was created to say this survey, this question ID. Then this is the survey, which what they call project. And one of these should be the answer one. Basically, those are our dimensions. And let's see. I think I'm out of time, but are there any questions? That's basically a simple thing. I should mention, because I think it's pretty cool, is all that runs every day. I won't show it to you here, but the cost of that is less than $10 a month. Runs every day.
That is pretty cool. On that note, we do have a question from Nirmal, if you want to come off mute.
Yeah, thank you. So my question is that while using CSV files and processing those files, did you run into any performance issue when you were trying to slap SQL on-demand views on top of it? And my second question is that was there any consideration of using Parquet files instead of CSV files?
I mean, there is, when you do use the serverless, it doesn't respond immediately, for sure. Because every time you run it is when it goes and runs through those files. You probably don't necessarily want to use that for live all the time loading or querying, but in this situation, you know, the pause of 2 or 3 or 5 seconds, depending on how many files and the size of the files, things like that, is irrelevant because the machine's running it, right? It doesn't care. It's just sitting, waiting. It's happy. If you're loading, you'd want to, if you're using it for something like Power BI, you would probably want to load that into something like a Power BI data set so that that would process at a certain time or process every half hour or however you want to do it. Because as a user, yes, it can get noticeable and you know, it's not like querying a database. There's a second part to your question. What was that?
Yeah, that was the same. Was the question like, was there any consideration for using Parquet instead of CSV? Because some people say that they are expensive to create Parquet files, but they are much faster to access.
For the CI Ken, we didn't. For the project we're working on now, we did. Again, the files are not huge. This whole process takes 9 minutes. So, you know, whoops, where's the pipeline run? There we go. Basically it takes 9 minutes and it runs, this is Eastern time, so it runs at 8 p.m. at night. No one's noticing how long it's taking for this case. Again, depending on your use case, yes, you would do different things. But like I said, don't focus always on the large because we're doing this very, very small. And you know, you have massive options, but we're doing a small project that has very, very low costs per month, just because those are what we chose to do. And that's what we tried to optimize for. So thank you very much.